Hello, calculus student. This video is for chapter 3.4, which is work problem. After we learn how to find derivative using, the common quotient rule, product rules, and power rule, we actually can solve a lot of work problem. The first work problem is about motion along a line. That means horizontal. So these are not affected by the gravity. So it's just because of people driving. So S of t would be the position function that represent what the location of the vehicle or the objects at time t. Velocity we know is s prime of t. So if we do a derivative of s of t, then you have velocity. The speed, that means how fast that particular car or object is traveling, is the absolute value of velocity. Velocity has positive, negative. It can be going backward and forward. So normally we would say this to the right is forward, to the left is backward. So that's velocity. Negative and positive has meaning, but speed doesn't have. It's just mean how fast you're going. Acceleration at time t is a of t, which is the second derivative of t or the first derivative of this velocity. So you do the first derivative to find velocity, and then you did a second derivative to find the acceleration. And in the horizontal motion, if the velocity is positive, that means you are traveling to the right. If the velocity is negative, it's traveling to the left. If the velocity is zero, that means the object stop. Okay. So let's move on to the next page, which is an example. So this is the function that describe how this we call it the particles that move along a horizontal axis. S of t is t cubed minus 12t minus 1. That means if you plug in t, you would know the position of the object. It could be negative. It's not above the ground or below the ground things. When will the object at rest? At rest means it's not moving. Velocity is equal to 0 would be when it is at rest, right? So we would find the velocity by doing f prime of t. We do a derivative of this. Power rule, 3t squared minus 12t minus 12. Okay, so that is the velocity. At rest means solving this equal to 0. So 3, so you will say at rest would be 3t squared minus 12 equal to 0. So factor the 3 out would be t squared minus 4 equal to 0. This is factorable. So if we factor it, 3t minus 2, t plus 2 equal to 0. So at time equal to 2, or at t equal to negative 2, which doesn't make sense. Time cannot be negative. So at time equal to 2, it would be at rest. So this is the answer. Okay, B part. What is the acceleration when the object is at rest? So when it is at rest, is it still moving, like it's like you like push forward, but you are resting, or you are braking, or you are trying to start again? Okay, so let's look at acceleration. So we don't have the acceleration function. We only have s prime of t calculated here. So we would do f double prime of t, which give us acceleration. It describes how velocity change. 2 times 3, 6t. And that's it. Okay. So what is the acceleration when it is at rest? So we would plug in t equal to 12. So f double prime of 12 of t is 2 is equal to 6 times 2 equal to 12. They didn't tell us what unit it is, so I don't know what unit it is. Unit per time square, right? Time period square. If we are to give them. So is the object moving to the right at time t equal to 1? So at time t equal to 1, we would have to look at if it is moving. So we use f prime of 1. Prime of 1 will be 3 times 1 square minus 12 is less than 0. So it's not moving to the right. No. So S prime of 1 is less than 0. So it's moving to the left. Is the object slowing down or speeding up at time equal to 1? So we'll plug in, so we already know that S prime of 1, the velocity is negative, but A prime of 1, which is S double prime of 1, is, what was it? The function is 6t, so it's 6 times 1 equal to 6 is positive. So it's accelerating, moving in the right direction, trying to move in the right direction, but at the same time, your car is actually moving to the left. So are you slowing down? It should be slowing down because v of x is negative, but v of 1, okay, but a of 1 is positive. They are moving in different directions, so it is a slow down. If they're both going to the positive direction, that means the velocity will be more and more positive. So, but in this case, it is slowing down because while the velocity want to go to the negative direction, your acceleration is pulling it back. Your acceleration is positive. That means your acceleration is trying to push it back to this other side. So it is a slow down. Example 2 is about a vertical motion. So when you have vertical motion, the motion is affected by gravity of negative 16t squared. And we know that there are 3 parts of the s of t function. This is about gravity. This is about if there's a force that push it up or down. Positive means it is being launched up vertically upward, right? This is positive. And 85 just means how tall that particular rocket is located in the beginning. Okay, so find the velocity after 0.5 seconds. So I just need to do S prime of t first and then plug in 0.5 later. So negative 32, because negative 16 times 2 is 32, and t to the 1, right? Plus 100. And that's it. That's the velocity as f prime of 0.5. So I would do negative 32 times 0.5 plus 100 is 84. So it is feet per second. And you can see that it's positive. That means it's still going up. Still going up. When will the rocket reach the maximum height? So this rocket is being pushed, spiral, like in a tall building, right? And then supposed to go down like this because of gravity. Eventually it go down until you have an escape velocity that escape the atmosphere. When would the rocket reach the maximum height? It would reach the maximum height when velocity is 0. So v is 0 is when it is like stop moving, it stop going up. Then it is when it is a maximum height time, right? So no, v of t is equal to 0, not v of 0. V of t equal to 0. In the beginning is 100. So we don't have to do v of t. So we solve this negative 30t plus 100. This is the velocity equal to 0. That means 100 equal to 32t. And after you solve it, t is equal to 100 over 32. That is 3.125. At this time, it's going to reach its maximum height. This is the time second. After 3 seconds, it's going to reach its maximum height and begin to pull down by gravity. Find the acceleration at 0.5 seconds. Well, what is acceleration? Is s double prime of t. Okay, our s prime of t is negative 32t. F double prime would just be negative 32, right? Feet per second square. So, do I have to plug in anything? No. So, at any number you plug in, is a gravitational constant. It's always pulling you by 32 feet per second. That means the velocity is always going to decrease by 32 every time. How long will the rocket stay in the air? So it stays in the air if you to draw a picture. If you have a rocket and it reaches the ground. So we'll look at how the rocket will reach the ground. What is the time it will reach the ground? So let's plug it let's say S is equal to 0. So S is 0 is when it reached the ground. We will say 0 equal to negative 16 t squared plus 100 t plus 85. It's a quadratic equation solved by quadratic formula. T equal to so continue. We are to solve it by quadratic formula. So the way you do it is we just calculate negative b, right? Negative 100 plus or minus b squared, 100 squared minus 4 times 16, negative 16 times 85 all over negative 32. So if you simplify everything, it would have two answers, negative 0.758, which doesn't make sense. Time cannot be negative, so this is a extraneous solution. And also another t is 7.0081. So we stay in the air for 7 minutes. So it would be you fire it up, it fall down. This is totally 7 minutes. Determine what the velocity is upon impact. So I mean at time t, what is the velocity? So you have your f prime already. F prime is of 7. Let's just round it to 7. Would be what? Negative 32 t plus 100 is negative 32 t plus 100. And then our 7 is negative 32 times 7 plus 100. What would that be? So it should be going down. Negative 32 times 7 plus 100. So that is equal to negative 124 feet per second. When it reached the ground, the velocity is negative 124 feet per second. The second application, do I have enough time, is a change in times of population. So if P of t is the population at time t, and you do a derivative of P prime of t, then when it is positive, that means its population is growing. If it's negative, that means the population is decreasing. P double prime of t, that means the rate is increasing. If it's positive, that means the rate of the growth rate is decreasing. Okay, so then the third application is in business. It's about cost, revenue, profit in general. Profit is revenues minus cost. And then C prime, R prime, P prime are the derivative of it, and also known as marginal cost. Marginal because it describes how much your cost or revenue or profit will change if you increase one more item. Okay, so and then because of this definition of marginal profit and marginal revenue, the additional profit or additional cost or additional revenue that you get from selling x plus 1 item is p prime of x. So that means you want to find out, if I sell the 25th item, what is the profit that I will get? You plug in p prime of 24, it would tells you, because p prime of 24 tells you what profit is increasing per increase. So when you increase to 25th, it would tells you this number would tells you what the additional profit that you would have. So that is in general how you do this kind of work problem. Rate of change tells you how the original function is changing.